In this nugget, you and I get to take a look at a couple older technologies that we won't see too much anymore in current networks, as well as a newer one with VPN concentrators. Let's begin. Back in the 1980s, when I first began my networking career, the internet still existed, but it was nothing like it is today. It wasn't really available to everybody back in the 80s. So if we have a user like Bob, who normally sits at this computer and then accesses the file server as a resource here, if Bob goes home and he's sitting at his house, so this is Bob's house, how can Bob get access to those same resources without having to drive in? And one of the answers back in those early days was to use another cloud, except this cloud was called the PSTN, which stands for the Public Switched Telephone Network. So Bob's house had a telephone line, and this was an analog circuit to that phone. So Bob picks up the phone, there's dial tone, and it's an analog signal from his phone and from his house to the edge of the network. Well, unfortunately, Bob's computer is not an analog device, it's digital. So how in the world do we get a digital device to communicate across an analog network? And the answer is we need to get a translator. And that translator has a name called a modem. And modem itself is a shortcut of two different words, of modulator and demodulator. However, you and I can just think of a modem as a translator between digital and analog, two different types of signaling. So Bob's PC would have a cable that connected to the modem, and there would be another connection on the modem for the phone connector, and that's how Bob could connect his computer to the public switch telephone network. And of course, at the headquarters site, we'd have another little modem here, or it could be a bank of modems. Oftentimes, that would be integrated into a line card on this router, and then this router could be referred to as a network access server, or NAS for short. Sometimes it's also referred to as an NAD for network access device. It simply means that when Bob wants to connect to the corporate network, his PC connects to an analog modem, which allows the circuit across the public switch telephone network to connect to the modem on the network access server and give him access into the network. So an analog modem is something that I haven't personally used in probably over a decade. However, as a backup solution or an alternate method to reach our gear that we need to manage, we still may have some analog modems in place today. But if they are there, they are rarely used. And the sound that an analog modem makes as it's negotiating and establishing a connection sounds something like this. And on your smartphone, if you currently use that as the ringtone for your smartphone, brother, it's me. Because I think that is really, really fun. Another throwback to a different time is the hub. And unfortunately, hub is not an acronym for anything. It's just a word, hub. And one of the things about hubs is that they look a lot like switches. So for example, if we replace these labels with hub, hub 1, and hub 2, and we change the icon on the top to represent a hub, to the end users on this network that isn't very busy, they may not notice the difference. However, behind the covers, the details of the hub is significantly different. In our earlier nugget, we took a look at switches and how switches make forwarding decisions based on layer 2 addresses, such as MAC addresses on an Ethernet network. Well, a hub is not that smart. It's not as smart as a switch, and it doesn't have any clue that there's any such thing as a layer 2 address. So the hub, if we're going to compartmentalize its functionality, it is considered a layer 1 device. Because all the hub does, it receives bits in on a port and it simply repeats them on the other ports. So in our topology here, if these two devices were hubs and computer 1 sends information out into the network, the hub is simply going to send it everywhere. I'll send it to the printer, I'll send it to the access point, I'll send it to the router, I'll send it down to hub 2, I'll send it out to the internal server, and I'll send it out to the computer. And unfortunately, if that message was only for one device, all the other devices had to waste a little bit of time in looking at those signals that were coming in. And another bummer about a hub is that only one device can communicate on the network at any given time if we're using a hub. And the reason for that is because the signal is sent everywhere. In a switched environment where we have the signals being sent from one port to another specific port, it's possible to have multiple communications happening simultaneously. However, in a hub, it's one person only getting to talk at any given time. So a hub is a layer 1 device. It kind of physically looks like a switch because it has ports like a switch, but it acts and smells like a dumb repeater. That's because at layer 1, it's just repeating whatever it hears coming on one port. It repeats those signals on every other port. So for those reasons, we rarely, if ever, use hubs in our production networks. Instead, we use a layer 2 device called a switch that's more intelligent. Now, in the 21st century, if we have a user like Bob who is normally using this computer here, but happens to have gone home some evening or is home for the weekend, and now he's at his house, it's very likely that Bob's house is connected to the internet. And that could be through cable modem or DSL or some other high-speed mechanism. And today, it's very likely that if Bob needs access to the corporate resources, for example, this internal server, it's very unlikely that Bob is going to use an analog modem to connect when he has high-speed internet connectivity already in place. Now, here's the challenge. Even though Acme Incorporated is connected at high speed to the internet, and so is Bob, we don't want to send traffic over the internet naked, meaning plain text, not encrypted, because if we do, individuals or entities on the internet may eavesdrop on our traffic and see confidential information that they shouldn't have access to, such as our usernames and passwords. So to solve that, we're going to use something called a VPN. And VPN stands for Virtual Private Network. And virtual private networks today are going to use one of two technologies to implement their security. One is called IPsec, which stands for IP security, and the other is called SSL, which behind the scenes actually may be using something called transport layer security. And the details behind these protocols that are used as part of a virtual private network we'll save for another nugget. And as Bob builds a virtual private network from his PC at his house over to the corporate resources, that VPN tunnel has to terminate or end at some point. And one of our options is to use a VPN concentrator, which is a device that we could implement, and it's very likely going to be on our DMZ of our network. And then when Bob builds his connections, we could terminate to that VPN concentrator. So that way other employees like Lois and Sally and Kim and Julie, when they all build their remote access VPNs, and that's what RA stands for, by the way, is remote access VPN, a user out there on the internet building their own virtual private network to corporate headquarters. And the benefit of using a VPN are, number one, we have confidentiality. And that's provided courtesy of something we like to call encryption. Encryption is the scrambling of data so that any unauthorized eyes or somebody who's looking at the data, if they're not authorized to see it, they won't be able to tell what the data is. It's all gobbledygook to them. The second benefit is authentication. For this VPN that Bob's building, Bob has the ability, using the technologies involved, to validate that this VPN concentrator really is Acme Incorporated's VPN concentrator, and not some other company's or some hacker's VPN concentrator. And conversely, The VPN concentrator will also have the ability to authenticate Bob and verify that it really is Bob, the authorized user who is supposed to have access to the inside resources and who is authorized to build the VPN. And the reason it's called a VPN concentrator is because it could potentially support hundreds or thousands or tens of thousands of simultaneous remote access connections from users coming from all over the globe. And many times, this VPN concentrator function isn't done in a separate appliance because many vendors, including Palo Alto, Checkpoint, and Cisco, have integrated that functionality of the VPN concentrator into their firewall solution. So the firewall could act as a unified threat management system as well as a VPN concentrator for being the termination point or the ending point for the remote access VPN sessions that are coming in. So comparatively, if we go back in the time machine 20 years ago, we'd see a whole bunch of users with analog modems building connections over the public switch telephone network to get access to corporate resources. And today, we're going to see very little, if any, analog modems, but instead we'll see high-speed connectivity to the internet and then using the technologies of IPsec or SSL to build virtual private networks over the internet to our corporate locations for the benefit of the confidentiality that VPN brings for us as we send our traffic over the public internet. In this nugget, we've discussed a couple of old technologies, including analog modems and hubs, which we don't use too much anymore, as well as a more current implementation of remote access, and that is by using some type of a VPN concentrator to terminate our remote access VPN sessions coming in from the internet. I have had a blast in this nugget. I'm glad that you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.